Now let us go to a particular formula that has to do with the two-set Venn diagram referred to as the De Morgan's law. Now the De Morgan's law are two results involving union, intersection, and complement. Now this is what the law says. It has two forms. They are: 1. A union B or complement can be written by virtue of the De Morgan's law as A complement intersection B complement. That means that if the two of them are union with a complement, you don't just bring the union again for the individual complement. It will be the A alone complement rather intersection B complement. So we are trying to say that this is equal to that. Now the next part of the law, the next way the law can be quoted is, now we'll take the intersection with the union. So take A intersection B complement is equal to A complement union B complement. So when you take their intersection to all complement, you open it up rather with a union and their individual complement. So that is how the De Morgan's law is. See how the three intersecting sets for a Venn diagram and their various regions are described. Now the region number 1, we talk about all the three sets intersecting. Set A, set B, set C has all of the three intersecting at the middle, where I have shaded now. Now the shaded one can be referred to as in their set operations as A intersection B intersection C. Or another way to refer to the intersection point where we shaded this particular region, another way of calling it is A intersection B or intersection B intersection C. That is how you can also call it. So either A intersection B intersection C or A intersection B into brackets intersection B intersection C. So the two brackets then with an intersection. Another region will be the intersection of A and B only. That is called A intersection B only, where I've shaded up here. Now, that one is a description, and then that is a shaded region. But if you want the set operations, this is how you can describe A intersection B intersection C complement. Since C is left without shading, that means the region around C has no shaded area or is not being talked about. The C will be complemented because it will have members in the universal set that will not be in the set C. That is how it is done. So this shaded region here becomes A intersection B intersection C complement. That is a description. So take note of that. The next description will be number 3, region number 3. Here. So this one is called B intersection C only by looking at the diagram or where the shaded area is. It is the B intersection C or the intersection of B and C only where the A is not part or the region A is not part. So that one can be described with a set operation as B intersection C intersection A complement. A complement because the region A itself, the entire A as a subset, has not been shaded. So the A is not part. It means that the members in the universal set, there are some members that are not in the set A, and that is why it has been complemented here. Part of that particular region will be the region number 4. That is A intersection C only, where I have shaded. This region shaded becomes A intersection C only. And if you are describing it, it will become A intersection B complement intersection C. Meaning that B has no region shaded so far. So there are members in the universal set that do not belong to the region B. And that is why the complement is on B. So this region, by description for the set operations, will be A intersection B complement intersection C. 5 will be the region where A alone has been shaded. In this diagram, we check the A alone has been shaded, meaning that the intersections are not part. So we separated the A alone. And this has a description with a set operation as A intersection B complement intersection C complement, meaning the A is now part of the set, but the B complement and the C complement, they are having members in the universal set that are not in the set B and the set C. Now let's continue. To region number 6, we talk about B alone or B only. So among the three sets, we shaded only B. That is the area that belongs to B only. And it can be described as A complement intersection B intersection C complement. The final one will be the region for C only. So among the three sets, C only has been shaded from this diagram. Then we call that one A complement intersection B complement intersection C. So these are the descriptions for the regions of the Venn diagram under 2 sets and under 3 sets. So please take note of that. You can pause your video, get the description well, and then understand how they are. Now let's solve questions with the operations under sets.